Hello, welcome back. In this video we'll discuss the ruby laser. A ruby laser is a solid state laser because we are using a ruby rod. The light that is emitted from the ruby laser will be in the form of pulses. So it is a pulsed laser. Since it is a pulsed laser, we can easily guess about its pumping scheme. It is a 3-level laser, means the pumping scheme involves 3 energy levels. Now we can state ruby laser as a ruby laser can be stated as a 3-level pulsed solid state laser. Suppose you have the ruby laser like this. From this we get pulse of light for a short duration, and for another short duration there will be no light and again light. So there will be light emerging from the ruby laser in the form of pulses. A train of light pulses will be emerging from the ruby laser, hence it is a pulsed laser. The chemical composition of ruby is aluminum oxide doped with chromium 3+. The chromium in aluminum oxide will be present in the 3+ form. Here aluminum oxide is the host crystal and chromium is the dopant. The dopant will be present in chromium 3+ state. We take the ruby crystal in the form of a cylindrical rod. Generally the length of the cylinder is about 10 centimeters and its diameter is about a centimeter or 0.5 centimeters. Construction of ruby laser. We take the ruby crystal in the form of a cylindrical rod. Both the end faces of the cylinder are polished and they are made parallel to each other and perpendicular to the axis of the cylinder. This end of the ruby rod is coated with fully reflecting material, and on this side we have silver coating but it partially reflects. Enclose the ruby rod in a glass tube. This is the glass tube. We need a coolant. The coolant could be liquid nitrogen or air. All around the glass tube you have the xenon discharge tube or xenon flash lamp. We have a power source to power the xenon flash lamp. From the partially reflecting face we get the laser beam coming from the ruby rod. The ruby rod is taken in the form of a cylinder of approximately 10 centimeter in length and 1 centimeter or 0.5 centimeters diameter. In the ruby rod, chromium 3+ ions are responsible for lasing. The lasing transitions, they occur only in the chromium 3+ ions but not in the aluminum oxide. Aluminum oxide is inert in this case. Both the ends of the ruby rod are polished such that the end faces are exactly parallel and are also perpendicular to the axis of the rod. After polishing and applying the silver coating on either faces of the ruby rod, we can construct an optical resonator. So the ruby rod itself is going to work as an optical resonator in the case of a ruby laser. Next, pumping. Optical pumping is used in ruby laser because ruby is a transparent solid. The active medium is the ruby rod itself. Now we shall look at the energy level diagram of the ruby laser. From the xenon flash lamp we get white light. When high intensity of white light falls on the ruby rod, the chromium ions will be excited. Since the white light contains blue color as well as the green color and other colors also, the chromium ions can absorb blue light and also the green light. Only these two colors will be absorbed by the chromium ions. When the chromium ions absorbs the green color light, the ions will be excited from E1 state to E3 band. E3 is a band of energy levels. Similarly, when the chromium ions they absorb the blue color light, a transition from E1 to E4 takes place. So the green light absorption excites the chromium ions from E1 state to E3 state, and blue light excites the chromium ions from E1 energy level to E4 energy level. So this is how the excitation takes place or the upward transition takes place. From E4, the electrons will make a non-radiative transition to E2. This is a downward transition. So from E4, a downward transition to E2 occurs. Please note that there are two energy levels that are very closely spaced in E2. This is not a single state, it is having a splitting. A downward transition from E4 to E2 is a non-radiative transition. It releases heat. Similarly, a downward transition from E3 to E2 is a non-radiative and releases heat. And here E2 is the metastable state, and the lifetime of the metastable states is close to 1000 times more than E4 and E3. So the population of E2 state keeps on building up. As a result, population inversion occurs between E2 and E1. Downward transition from E2 to E1, this is a lasing transition. The pumping method that we are using is optical pumping. So the upward transition is initially due to the absorption of green light and the blue light. When green light is absorbed by the chromium ions, an upward transition from ground state E1 to E3 takes place. Similarly, when blue light is absorbed, an upward transition from E1 to E4 takes place. From these two energy bands, the chromium ions, they make a downward transition quickly to a state E2. E2 is a metastable state. The chromium ions population in E2 keeps building up. So a transition from E4 to E2 happens, and this is a non-radiative transition. As a result, heat is released. Similarly, a transition from E3 to E2 takes place. That is also a non-radiative transition. When a stimulated downward transition happens from the upper energy level of E2 to the ground state, we get the lasing, which will be in 692.7 nanometers. And similarly, a transition from the lower energy level of E2 to the ground state gives rise to lasing in 694.3 nanometers. Now we shall look at the working. Chromium 3 plus are excited to E3 and E4 bands of energies. From E4 and E3, a non-radiative spontaneous downward transition occurs. E2 energy level is the metastable state. Lifetime of E2 is about 1000 times greater than E3 and E4. Hence, population of E2 builds up. Population inversion between E2 and E1 is established. A stimulated emission downward transition results in the lasing. One can get 694.3 nanometers and 692.7 nanometer radiation. 694.3 nanometer radiation will be much greater than 692.7 nanometer radiation intensity. Transitions from E4 and E3 to E2 energy level generates heat. Hence, a cooling is provided. In this video, we have started our discussion by characterizing the ruby laser. We have said ruby laser is a 3-level pulsed solid-state laser. The chemical composition of ruby is aluminum oxide doped with chromium. The chromium exists in the form of chromium 3 plus in the aluminum oxide host. The ruby rod is taken in the form of a cylinder, and the length of the ruby rod will be about 10 centimeters, and its diameter would be about a centimeter or half a centimeter. We have seen the construction of the ruby laser. We have seen that chromium 3 plus ions are responsible for lasing in ruby laser. We have seen how the optical resonator is constructed in the case of a ruby laser by polishing both the ends and applying reflection coating on both the sides. We have seen the energy level diagram of the chromium 3 plus ions in the aluminum oxide lattice. We have also seen the upward and downward transitions and the lasing transitions. We have seen the working of the ruby laser. We have seen how population inversion happens between E2 and E1 energy levels. We have said that 694.3 nanometers and 692.7 nanometers wavelength can be obtained from a ruby laser. We also said that the transitions from E4 and E3 to the metastable state are non-radiative, hence they generate a lot of heat. To maintain the temperature of the ruby laser, hence a coolant is needed. Thank you.